All right, so our next phase of the fixture here is going to be machining our copper plate. We're going to go ahead and get that finished up today. So we have, there's a drawing of what we're going to be doing. We've got to drill and countersink the holes in the ends, that's for the screws to hold it down. Then we've got a pocket to mill, and then we have holes to drill in it. And that's it there. Now, one thing I was going to point out to you, I bought this from McMaster Car, and it was a 12-inch length of stock. And I figured 12-inch length of stock, they usually cut it a little bit long. This one, they actually did not cut it long. It's slightly under 12 inches, so it's already under the finish length of 12 inches. It's not going to hurt anything, but I just want to point that out. So as we finish up this fixture, you're going to see that this copper plate is going to be shorter than the length of the actual fixture itself. Probably by about 30 thousandths on each side of it there. All right. So I went down to the local hardware store to pick up some fresh bolts just for this job right there. I got these guys right here. These are some grade A. I wanted the black oxide, but they didn't carry the black oxide at my hardware store. So I just got these right here. And then as far as the cap head screws, the same thing. I wanted some black oxide flathead bolts, and all they had in the size I needed was stainless steel. So I just went ahead and grabbed them when I was there. And if these need to be swapped out for steel, we can do that later on. But I wanted to have some screws on hand for getting this done today, so I just went ahead and picked them up. I got two different lengths, by the way. I got 1/2 inch long and 3/4 long because I wasn't sure which one I might need, so I just got all 4 of them there anyway. But it's nice going down the street to my local hardware store. They just don't have the selection that McMaster Car is going to have, you know what I mean? So anyway, let's go over to the mill and get this set up, get started on it. I'm going to use the same type of setup here like we did when we milled the clamp bars. Just making sure the vise is cleaned out there. We're going to use our edge multi-axis stop. I'm going to get our parallels in there. And we're going to use the edge parallel separator to hold the parallels flush against the vise jaws. All right, so I just want to clean the ends up. So we'll take maybe like 10 thousandths just to kind of clean the end up, and then flip it around, clean the other end up as well. We got our cool Noga Sample pack of these 3/8 carbide end mills. So I believe what we're going to try is the A345 on this job. That guy right there. Let's try 5 thousandths, see if it cleans it up. Just trying to clean the saw cut. I think 5 thousandths is going to work fine. Alright, let's move another 5. Yeah, I think that's going to look good. I'm going to use my edge finder now, and we're going to find the center of it, and we're going to offset it the proper distance from this end. We'll go ahead and do our drill, countersink this in, flip the bar around, do the same thing. That'll put us on center line working off the stop there. Just using the DRO to split the difference, take us to 0. Distance from the end nominal is going to be 1/4 inch, but we're moving at 210 thousandths. Plus another 100 thousandths because of the diameter of the edge finder. I want to spot both the holes first and measure it, make sure that I'm on my 11.5 center line. So we're just going to spot it like that, and then we'll flip it around. All right, let me get my calipers and we'll check it. All right, we got it set at 11.5. Just putting this one down in the center of this divot on the left end and dropping this one down, and it looks like we're correct. 11.5, so we're good to go. I'm going to be using an 11/64 drill bit for our clearance hole for the screw. Just using some tap magic right here for aluminum. This is also good for copper. All right, good clearance hole for the screw. I'm going to go ahead and flip it around, do the other side before we do our countersink. All right, let's do our countersink now. I'm going to run the quill down against the stop up here. And we'll feed the knee up, that way it'll be at a stop depth for the other side. I'm just cranking the knee up a little at a time there. We're just going to cut it until it sits flush. A little bit more. That looks pretty good right there. That's just below the surface. Yep. I'm going to go up another 5 thousandths right there. Okay, I like that. That looks good. We're going to leave it right where it's at. Now that I got the knee raised to the right depth, I can come down on my stop gently. There we go. Okay, that looks good. We got our 2 holes finished now, drill countersink. So now we're going to reset. We're going to put this in the center now to do our milling and drilling for the center slot. We've got the bar centered there, and I'm putting these machinist jacks, these are just little giant jacks. I'm putting underneath both ends to support it from being pushed down, just giving enough friction there to hold it. And we've got that one there as well. We'll see how that does when I touch off. It's possible we might have to come in there and actually put a clamp on it to hold it down against the jack, but we're going to try it without it. So we've got that's that 5 flute end mill that we used earlier to skin the sides, so we're going to give that a try. I've already moved down, so the way this centers out is that it's 11/16 from the ends is where it'll center out. And we're coming down onto a stop right there, so I will feed the knee up as far as our depth goes. It's going to try to chatter on me, so I think I'm going to definitely need to put some clamps on here. Before getting the clamps on, I want to offset it down to the other end to make sure that I'm good on my center. Should be 10 5/8 is the total length there. And it looks like it's matching up there, same as the other end, but I'll measure it and make sure that we're good there. I got a shim in there, a piece of aluminum to protect marring the copper. A little stack up here with the step block. And it doesn't take much, just enough to hold it flat down against that solid jack surface. I'm going to try both the aluminum Tap Magic and then my Noga Cool as well. See what helps here. I think what I want to do is go ahead and set up my Cool Mist, the Noga Cool, so that we can blow the chips away while we're cutting. I've got it down to the depth I want. I'm going to start off feeding it by hand just to kind of get a feel for that end mill if it's going to try to load up with this copper. go, end of the line. That did really good. That looks nice. The cool mist is definitely the way to go on that, trying to evacuate the chips and get them out of the cutter there. We're coming back down with the Tim 1000s out of that side. So I'll clean up that right there. Make it look a little nicer. I'm just having to manually turn this as we go since it's mounted on the machine. I got to get in here on our center point and drill a hole in the original swivel pad, just a little bit in the way. And when you come off out of the way, it kind of kicks over. So perfect use of the optional point that comes with the little giant jack here. So we'll be able to run this jack, the cone tip there, right up into that drilled hole, and give it a nice solid mount for pushing down there. Alrighty, we're ready to start drilling holes. So we're drilling using a 3/32 drill bit. That's one of my screw machine link drills there with the split point. It should do a good job of centering up and drilling that hole. We don't have very far to go through there. Our center to center distance is a 1/4 inch, so I'll just drill one and step it over a 1/4 and just keep it going. I think I'm going to try the tap magic for this right here. Since we got a trough there, it should kind of keep it down in there. Running the fastest speed I got, which is 2720. Yep, that's doing good. It ain't much. Yeah, this is going to be a simple op. Alright, so we got all of our holes drilled. That was the last machining op there, so we're pretty much done. We got to deburr it. We'll get it out of here, we'll get all the holes deburred, and then we'll fit it up on the purge fixture and see what it looks like. You can see all our burrs there that we need to get off, so I'm going to use this Noga multi-tool right here. This has got the little countersink whirligig tool right there. And it should work really good for this. Just stick it on there and give it a few spins, and it takes it right on off. The ones in the middle that I did. There's half of them done. All right, so there's our copper block, all finished up. There's one more detail we're going to do whenever I test fit it right here. We got a couple of our flathead bolts. All right, there it is. Okay. Then we got our clamp bolts that'll go right here. Clamp plates. Looking more complete every time. Really liking it. So what I want to do is go ahead and give this copper a nice little polish. I didn't want to machine it to change the dimensions of the, the naturally rolled extrusion there. But I've got a nice polishing cloth that always works really good for any kind of polishing jobs, especially aluminum and copper. And I'm going to use it on this aluminum once we're ready to, our final assembly. But I'm going to give this copper a nice polish and see the difference between the raw copper like it is right now and a polished finish. So let me go grab my polishing cloth and I'll be right back. So this is what I like to use right here. This is it says Miracle All-Purpose Polishing Cloth with real coconut oil. It works excellent for brass and copper and aluminum and things like that. And I've been using these cloths for years, and the reason why is because it works great. And I buy these off Amazon, and they're only like $8, just over $8. So I'll have a link to this for the Amazon, where you can purchase it off Amazon in the video description below if you want to get you one and try it. But this is a brand new, and I just ordered it because I checked out my other one the other day, and the one I've had for a while, and they do go bad after a while. They start getting dry. So what I do is whenever I use it, I put it in a Ziploc bag, so I can seal it up. But I'm going to take this one out, and what I'm going to do is actually cut it into a smaller piece so I don't use the whole thing just for this job. Let's make it into 3 pieces. It's got a very pleasant smell to it. It smells like coconut. And let's go ahead and give it a little rub in the middle there. Let's see what it does. And it turns black as you polish it. That's normal. Alright, there's a spot right in the middle just so that we can kind of compare. And I like to keep these microfiber cloths handy for polishing. So I got a couple out of here and use those to buff it. And look at that. See the difference between the two? This is the one I polished, and then that one I didn't. It looks good. I can't wait to see the whole thing like that. So that's why I didn't worry about machining it, just because I know the polish is going to make it look really good. So I'm going to go ahead and polish the rest of it out. When we get it done, I'll bring you back so you can see what it looks like. There's just the top side done. Still got to do all the other sides there. All right, what you think of that? That copper Sure looks nice whenever it's polished out. Still getting my fingerprints on it just from it being on my gloves here, but that's all right. Looks real nice on there. Once we get through with everything, I'm going to give the aluminum block a nice polish too. It's going to be so pretty, Jody ain't going to want to use it and get any scratches on it. Let's go ahead and finish putting it all together here. Looking good. Almost complete, but really liking the way that copper looks. Man, it's just got such a nice contrast against the aluminum and steel. Very cool. All right, so we got one more op to do. So our next thing is going to be finishing out our tube that's going to go down through there. We got our copper, got our brass tube right here that's going to go down the center. We're going to machine a hole through this so that it can be slipped onto this rod right here and soldered on. We've also got to set up and do just like we did the copper. We need to drill a bunch of holes in the cap so that it'll transfer the gas out into the valley there into that pocket. But that'll be our last, it's going to be our last machining op right there. So we'll see you again soon on the next video.